Hey guys, welcome back to another science lesson with HKM Math and Science. In this video, we'll be learning about heat and mainly to understand the different ways in which heat transfer occurs. So by the end of this lesson, we should all be able to describe the particle model, be able to describe how heat is transferred through conduction, how heat is transferred through convection, and how heat is transferred through radiation. Alright, so let's pause the video here and take a minute to write these down. So before we learn about how heat transfer occurs, we need to know a bit about the particle model. So the particle model is about how the particles in a solid, liquid, gas are packed and how they move around. So in a solid, the particles are tightly packed and vibrate, but they keep the shape of the object. Like we can see in the left image here, they are tightly packed and we can see it roughly forms a cube shape. In a liquid, the particles are still packed closely and vibrate, but they are also free to move or flow over each other. And in a gas, particles are not bound at all and are free to move in straight lines until they collide with other gas particles or walls of the container. So that's all depicted in these three images: solid on the left, liquid in the middle, and gas on the right. So heating an object will change how the particles move and vibrate. So increasing the temperature of an object makes the particle inside it move faster and faster. This spreads the particles further apart, causing the object to expand. So in a solid, if you heat it up, it will enlarge just a little bit. And in a balloon, if it's filled with gas and we heat that up, the balloon will also expand. Decreasing the temperature of an object makes the particle inside it move slower, and the particles don't spread as fast, so the object contracts. So that's the opposite effect from that first stop point here. It will go from a bigger object to a bit smaller. When there is enough heat energy, the particles break free from each other and the object changes state and melts or evaporates. So let's use water as an example for this image on the left. It will be an ice cube if it's cold enough and doesn't have as much energy, because the particles won't be moving that much. If it gets heated up a bit, it will turn into a liquid. And then if that gets heated up even more, it will turn into water vapor or steam. Alright, so this GIF over here also depicts that. In a colder environment, it will only move around a little bit. A bit warmer, it will move around a bit more. And in around 40 degrees, it will move even more than that. Alright, so this website here is just the link I had on the PowerPoint before. It's a little interactive of how particles move between solids, liquids, and gas. So let's have a go at playing around with this. We're going to start off with water in its solid form or ice. So that's around negative 127 degrees. That is very cold. So the particles aren't moving that much. They're just vibrating very little. So let's heat that up a bit. Let's heat it up to just over 1 degrees. Now it is much more free flowing. The particles are moving much more because now it is now in the liquid form. Let's click liquid here. So we've gone even higher temperature to about 13 degrees. And now they're just moving even more and they've taken the shape of the container. Alright, now let's heat this up even more. So let's put on the heat that up. Let's heat that, and notice how it's starting to move more and more as it gets hotter. So now that's in the gas form. Let's click gas as well. So in the gas form, when it's at around 156 degrees, that will start to happen over 100 because that's when water boils. That is how water will act as a gas. It's very free flowing. They bounce off each other and bounce off the containers of the wall. Alright, so that was a demonstration of what happens when you heat up an object. That was an example with water, and just remember that will happen with any other object as well. So if you heat it up enough, it will turn into a liquid and then it will turn into a gas. Alright, so now that we know how particles react or behave when they are heated or cooled down, we can move on to the topic of heat transfer. So heat flows from areas of higher temperature to areas of lower temperature. And the greater the temperature difference, the faster the flow of heat from one object to another. So if we're holding an ice cube, that means the heat from our hand will go into the ice. It's not the cold temperature of the ice going into our hand. It's just the heat escaping our hand. So the process of heat transfer can happen in three ways. These are known as conduction, convection, and radiation. So the first method of heat transfer we need to know is conduction. So this involves fast moving particles, lots of energy colliding with neighboring particles. This collision gives the colder and slower neighboring particles more energy, and therefore the neighboring particles start to vibrate faster. The formal definition of conduction is the process of heat transfer by vibrating particles. So if we look at this glass rod down here, we have the flame here on one end heating up the glass rod. So it's going to start heating up that area of the glass rod. So if you're holding a glass rod over time, your hand will start to get hot as well. That's because the glass rod is being heated up through conduction, and the vibrating particles will start hitting the other colder particles, making them vibrate more, or making the heat travel up the glass rod. Alright, so continuing on with conduction, we have some materials that conduct heat well, while others do not conduct heat at all. So let's think about a glass cup and a polystyrene cup. So let's think about both these filled with ice cold water. The glass cup will feel much colder than the polystyrene cup. This is because glass is a better heat conductor than polystyrene, so heat will flow from your hand into the cooler glass and your hand will start to feel cold. Also, substances that transfer heat easily are known as conductors. Metals are also a very good conductor, like we can see on the bottom right. That's why a lot of frying pans or cookware is made out of metal. So continuing on with that, the opposite of conductors are known as insulators. So some materials are very poor conductors of heat and sometimes can block heat transfer completely. So some examples of this are plastic, air, cloth, wood, and rubber. These materials or substances are known once again as insulators. This is why handles of frying pans are usually made from insulating materials, such as plastic, that's pretty common, to prevent your hands from burning. If the handle was also metal, that might get hot through conduction, making your hand burn. The second method in which heat is transferred is known as convection, and this is how heat is transferred in liquids and gases through the movement of particles. This does not occur in solids because the particles can only vibrate and they cannot move freely. Alright, so the process of convection can be broken down into 4 steps. The first of these is the air or liquid is heated. Second is particles gain energy and they start to move further apart. Third, the hotter particles are more spread out, which means they have a lower density because they're a bit lighter, and therefore they rise up. They rise towards the top, as we can see in these 2 images here. On the first one, they're moving up that way. In this one, they're also moving up. The part 4 is colder particles are close together, so they have a higher density, so that means they're heavier and they start to fall. And notice how there's a bit of a cycle going on. The warm air is pushed up, it gets cooler and starts to sink, and it starts going that way all the way around. Same with this in the boiling water. We get the hot water going up and the cold water going down. This airflow or water flow is called a convection current. So one of these, they're all just called convection currents. This is also how we get hot water in our showers or our taps. We have cold water coming in at the bottom. We have a little fire that boils the water, makes it hot, and that hot water rises while the cold water falls down to the bottom. So we have the output up the top because hot water rises to the hot taps like our shower or our kitchen sink. And that is how we get hot water through our water boilers. Right, now that brings us to our last method of heat transfer. This is known as radiation. So this is when heat is moved from one place to another without using particles, and radiation transmits heat as invisible waves known as infrared radiation. So this is the method in which sunlight transfers heat. Heat has traveled through the empty space between the sun and the earth, and heat cannot have been transferred by conduction or convection because there are no particles to vibrate or flow in space. So the amount of heat an object absorbs, reflects, or transmits depends on its material and its color. So dark colors such as black or gray, anything in that dark area, absorbs more heat. This is why white cars are cooler in the summer than black cars, because black cars will absorb that radiated heat. Light colors reflect the radiated heat, such as white or anything in that lighter spectrum. And clear materials such as glass transmit radiated heat, which means it just flows right through. So quick summary of this lesson: conduction only happens in solids, convection only happens in liquids and gases, and radiation does not use particles and can occur anywhere. Alright, so that brings us to the end of this lesson. Hopefully by now we all know about the particle model and can describe it. Can also describe how heat is transferred through conduction, how heat is transferred through convection, and how heat is transferred through radiation. Thank you for watching, and I'll see you guys all back online.
Boom! 2 + 2 is 4, -1, that's 3, quick maths.